Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yakoob. So now we are on lecture 4 of the foundation course, the smooth transition from O levels all the way till AS level. Now in today's lecture, let me focus on trigonometry. Let me focus on something regarding arcs and sectors and circles and segments and so on. Now, first of all, if I talk about trigonometry, so in trigonometry, we always talk with respect to a particular triangle. So let me draw a right angle triangle. So that is trigonometry. Hold for a second. So that is like a base. This is like a height. And this one is the hypotenuse. Now I'll be using this triangle a lot. So let me do this. Let me copy this thing and add this thing as an element. So now over here, is that an option? Yeah, create element and create element and then this grid. Okay. So now let me write symbolically over here. This is the angle theta. This is A. This is B. This is C. This is 90-degree angle. A is the opposite or perpendicular. B is adjacent or the base. C, the longer side, that is the hypotenuse. Now, when we talk about the opposite, that is with respect to this angle. It's opposite to this angle theta. So opposite and perpendicular, that is the terminology we are using. When we are talking about the base is the adjacent to this angle. So if one side is opposite, the other one is adjacent, this is the base. And the angle opposite the 90-degree angle. So opposite to the 90-degree angle, that is the hypotenuse, that is the longest side. We all know about this. We all are aware of the Pythagoras theorem. The symbols doesn't make a difference. The placement of symbols doesn't make a difference. C square is A square plus B square. So now what else is there? We can talk about sine and cos and tan. So sine of this angle theta, cosine of this angle theta, tangent of this angle theta. So sine is opposite over hypotenuse. So we know that sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tangent is opposite over adjacent. So sine theta, that is A over C. Cos theta is B over C. Tangent theta is A over B. No harm in double checking. Let me minimize it. So now over here, opposite hypotenuse, that is sine. Adjacent hypotenuse, that is cos. Opposite adjacent, that is tangent. So all good, all clear. Now, still we are studying trigonometry. And let me paste that triangle right over here. And let me plug in some values this time. So let me write this thing as theta. Let me write this thing as 3. This is 4. This is 5. It's a very famous triangle. So this is the most famous right angled triangle, the 3, 4, 5. How do I prove? Now, these are one of the things that they ask. Prove that the triangle is right angled. So for right now, I can just use it method 1. The longer side 5 square, is it equal to 3 square plus 4 square. If it's so, it's a right angle triangle. This is 25, this is 9, this is 16. Yes, both sides are equal. 25 equals to 25. Hence, I have proven that yes, it's a right angle triangle. A very simple proof. Now, let me do one other thing. That is this thing over here. Let me write down the value of sine theta. Let me write down the value of cos theta. Let me write down the value of tangent theta. So sine theta, this 3 is the opposite. So this 3 is the opposite. This 4 is the base. This 5 is the hypotenuse. So sine is opposite over hypotenuse. And cos is adjacent over hypotenuse. So 3/5 and 4/5. Let me first write it over here. So this is 3/5. This is 4/5. And tangent is opposite over adjacent. That is 3 over 4. So now, so far, what I have done is just a revision. And I hope it's all good, all clear. And let me just double check. So now all good so far. Just acknowledge this. Now I'll be putting some twist in it. So always keep your WhatsApp handy, because this acknowledgement, that is like I'm keeping aware that you're understanding it all and you also know where you're standing. So something very basic. Now let me do one thing. Now look at these three fractions. Now something a little bit out of the box. Look at this fraction 3 over 5. Look at this fraction 4 over 5. Look at this fraction 3 over 4. If I divide 3/4, actually 3/5 divided by 4/5. If I divide 3/5 by 4/5, that is 3/5 into 5 over 4. That comes out to be 3/4. Isn't this the same thing as this? Yes. What have I proven so far? I have proved something new, that tangent of theta for any angle, that is equals to sine theta over cos theta. That is a new identity, a relationship that I have created. So now this is sine 3/5, this is cos 4/5, this is tangent, that is 3/4. So it's a hard and fast rule. It's always true. Tangent theta is sine theta over cos theta. Now someone can say, maybe it's a coincidence. So let me prove it over here. Sine A over C, cos B over C, tangent A over B. Let's divide. So if this is true, that should be sine theta divided by cos theta. Sine theta is A over C divided by cos theta. That's B over C. This division sign will flip. A over C into C over B. What am I getting? A over B, isn't that equals to tangent theta? So far, so good. So I have worked with symbols. I have worked with numbers. So that is the first identity that I have created. Now this is first identity that I have created. That is T equals, where is the equal signs? Equals S divided by C. Tangent theta is sine theta over cos theta. That is the first thing that we have created. Now, let's talk a bit about similar triangles that we can talk in mensuration, lecture number 5, not right now. Now, let me do one other thing. We have sine theta is equals to 3 over 5. We have cos theta equals to 4 over 5. Let me take sine theta and let me square it. So that is 3/5 whole square. That is 9 over 16. Let me take cos theta and square it. So that is 4 over 5 whole square. That comes out to be 16 over 25. That is not 9 over 16. Let me correct myself. That is 9 over 25. And also, let me just write sine theta properly. So sine theta whole square is 9 over 25. Cos theta whole square is 16 over 25. Let's add sine theta whole square and cos theta whole square. What do I get? This is 9 over 25. This is 16 over 25. 9 plus 16 is 25. Denominator is the same. 25 over 25 is 1. And by the way, you can also acknowledge the first identity in the WhatsApp group, that is tangent theta is sine over cos. So we are working on sine theta, the whole thing square, cos theta, the whole thing square. When I add it, I'm getting a 1. Now, let's check this thing with another triangle. So let me take out this triangle. Let me place it over here. And let me write some values. This is 6. This is 8. This is 10. First of all, now this is like your classwork. Check whether it's a right angled triangle, yes or no. That is the first thing that you need to check. The second thing, write down the value of sine beta. Write down the value of cos beta. Write down the value of tangent beta. Double check the identity. Tangent beta, is it equal to sine beta over cos beta? Again, check. Evaluate sine beta whole square. Evaluate cos beta whole square. Does sine beta whole square plus cos beta whole square adds up to 1? That is for you to check. I have minimized it. Just have a look over here. Let me pause the recording. Acha ji, now let's look at this question. First of all, what you need to realize that this is exactly the same question as the previous one. Instead of 3, I wrote a 6. Instead of 8, I wrote a 4. Instead of 5, I wrote a 10. I doubled it. So technically, this is a similar triangle. This is a concept of similarity, and the scale factor was 2. Everything was doubled. 3 became 6, 4 became 8, 10 became 5, 5 became 10. Is it a right angle triangle? It should be, because it's similar. 10 square is equals to 6 square plus 8 square. This is 100. This is 36. This is 64. Yes, it's a right angle triangle. Sine of beta, that is 6 over 10. Cos of beta, that is 8 over 10. Tangent of beta, that is 6 over 8. Is tangent beta equals to sine over cos? Yes, it is. That is 6 over 10 divided by 8 over 10. After flipping, the 10 and the 10 cancels out, leaving behind 6 over 8. No need to reduce it. Sine of beta, the whole thing square, that is 6 over 10, the whole thing square, which is 36 over 100. Cos of beta, the whole thing square, that is 8 over 10 whole square, that is 64 over 100. Does it add up to 1? Yes. 36 over 100 plus 64 over 100, that adds up to 100 over 100, which is 1. That is, what is the new thing? I have found another identity, another relationship, that is sine theta, the whole thing square, plus cos theta, the whole thing square, adds up to 1. Is this all good, all clear? So this is the new ID that I have created, that is sine square plus cos square. This is adding up to 1. adds up to 1. So this is from the basics of O levels. I have taught you what is AS level. Just acknowledge it over here. Got the idea loud and clear. Now, let's talk about uh, non-right angle triangle. So now we are talking about non-right angled triangle. So now if I draw a non-right angle triangle, so let me draw a line, a red line, a blue line, a green line. Let's label it A, B, and C. Angle A opposite is side A, angle B opposite is sine B, is the value of B, and angle C opposite is small c. This is angle A, this is angle B, this is angle C. A, this is B, and this is C. Now, if I talk about area, so area is half AB sine of C. So two sides, and this is enclosed angle. So any two sides, if I choose A, if I choose B, then I'll be choosing C. If I choose C, if I choose B, I can choose angle A. If I choose C, if I choose A, I can choose angle B. This formula holds true. You can find the area of the triangle. So let me write over here. This is area of triangle. If I talk about cosine rule, so cosine rule has two implications. Three sides, find unknown angle. Or I could be given two sides and included angle. So enclosed, included means the same thing. I can find the third side. For example, if I use the same thing like A, B, C, so I can use A, B, and I can find C. So let me write over here. That is C square is equals to A square plus B square, just like Pythagoras, minus, put a big bracket, 2AB, and this is cosine of angle C. So now over here, if I have C over here, then there should be a C over here. So it corresponds to that. And then we have A and B, any two sides, and the included angle. So this is this thing. Two sides, included angle, find the third side. That is the application of this. What about find the unknown angle? So let's say if I make cosine C the subject, so therefore C square minus A square minus B square divided by 2AB with a negative sign, that is equals to cosine of C. Now in this shape, cosine of C, this is C square minus A square minus B square divided by negative, 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 and this 2AB. That is for three sides. Find the included angle, find the unknown angle. So if we are interested in angle C, it will be written from the perspective of C, or you can write this thing and then make the subject. That's your choice. This is cosine rule. What about the sine rule? So if I talk about sine rule, so if I talk about sine rule, that is angle and its opposite side. That's the relationship. You can find unknown side. You can find unknown angle. For example, if I write A over sine of A, B over sine of B, C over sine of C. You can write it like this, or you can flip each fraction, or you can write sine A over side A, sine B over side B, cos, not cos, this is all sine, that is sine C over small c. So this is all good, this is all good. You can take two fractions at once. So that means either you can just take this and this, equate, and you can find anything that's unknown. So maybe uh, if this thing, my bad, let me just correct one thing. That is this thing. Okay, the side thing was there. So let me again use this thing over here. So now what if this thing is unknown? So if A is unknown, so A is unknown, but you know angle A and you know the relation, you know these two things. So angle, opposite side, angle, opposite side. So out of these four, if any one is unknown, you can find that one. Similarly, if you know this, if you know this, if you know this, you can find this one. All good, all clear? So just a small recap. Non, right angle, trig. Is this all good, all clear? Now, let me talk about this with respect to another chapter that is technically 2D mensuration. And let me draw over here. Let's say, for a second, let me draw over here. Let me change the color, round it. Okay, and what about the stroke settings? Okay, there is the color. Where is the color? Okay, I think this must be the color. Yeah. Now let me draw a triangle. Let me draw a circle. This is a circle. Let me remove the color. Okay, the color is not being removed. Some issue. Let me draw a line from here to here. Now, the very first thing, that is this one is a minor segment. This one is a major segment. This one is a chord. We should also know that a semicircle is a special kind of chord which passes through center of circle. That will divide into equal halves, but this is just a simple chord. It divides into major segment, minor segment. Something like this. Let me draw a circle over here. And over here, let me draw two other lines. So now over here, two other lines like this and like this. So it's kind of okay. This is radius R, this is radius R, this is center O, this is A, this is B. Let me draw a line from A till B. Okay. So now this blue line over here, that is the chord AB. This green line over here, like this, the curvature, this thing over here, from here till here, this thing, this is arc length AB. This angle theta, this is the angle at the center. Now, if I talk about OAB, there is a triangle. And there is also a sector OAB. And if I shade this, that is a segment. This is a triangle. And in this question, this triangle plus segment, what does it add up to? It adds up to a sector. So therefore, the sector in this diagram is equals to the triangle OAB plus segment AB. Is this all good, all clear? Okay. Now let me share this image with you. So there is this thing, there is this export page, there is this image coming your way. Okay. Now keep this thing handy because now I'll be solving a problem based upon this. So now we are talking about trigonometry. And let me draw the same thing over here. And let me plug in some values. Okay, hold for a second. Okay. And eraser. And then we have some lines over here. Okay. So now this is O. This is O, this is A, this is B, this is 60 degrees. Let me draw a blue line. And let me mark off this thing. That is the shaded region, that is the segment. And what else? 10 centimeter, that is the radius, 10 centimeter, that is the radius. Now, the very first thing I want to calculate is that the length of chord AB, that is one thing I want to calculate. Now, what are the different ways that are coming to your mind? I think I'll just go ahead and use cosine rule. That is the most simple one. So let's use cosine rule. And I'll write AB whole square, that is equals to 10 square, 10 square minus 2 into 10 into 10 into cosine of 60 degrees. Now use your calculator, give me the cosine of 60 degrees. I remember it because it's a very nice number, which is half. Now let me take this 2. Let me take this half. If I multiply, what do I get? They cancel off. So now this is 10 square, this is 10 square, this is negative 10 square because of this. And then I'm left with 10 square, that is AB square. Therefore, AB comes out to be 10 centimeter. How do you like the working? How's the working? Okay, just give me an A star, a star, a tick mark, a like, so that you know exactly what I'm teaching you. So now I did not use a calculator. You might have used it to evaluate cos of 60. I remember this value. So that is half. This 2 and half cancels out. I did not even expand it. 10 square, 10 square, 10 square. These two 10 square cancels out. And 10 square is AB square. AB is 10. Now let me tell you another working for the same part. That is, I don't even have to do this. This is an isosceles triangle. So that means these two lengths are the same. That means if this is the angle theta, this is the angle theta. So theta plus 60 is 180. 2 theta is 120. Therefore, theta is 60 degrees. I think that is another beautiful working of isosceles triangle property. So this is isosceles triangle. That is why I got the answer loud and clear. So since it's an isosceles triangle, but now it has become an equilateral triangle. It was an isosceles triangle. Now it's an equilateral triangle. This is 60. This is 60. This is 60. Therefore, what is the conclusion? AB is also equals to 10 centimeter. So isosceles triangle became an equilateral triangle because of this thing, because of that angle being 60 degrees. Is this all good, all clear? Have a good look. Now, using the same diagram, let me pick this diagram from here. Let me carry it onto the next page. And this time, now I'll ask you to do some working. Copy and let me paste it over here. And let me just erase some extra stuff. So let me erase this thing. Let me erase this thing. Let me erase this thing. These two, this, these two. Okay. So now I need the following. I need area of triangle OAB. This is part B. I need part C, area of sector OAB. And then last but not the least, I need area of the shaded region. So now I need all these things. The screen is right in front of you. Let me pause the recording so that you can try it out. So now people, let's look at this question. It says part B, area of triangle OAB. We have two sides and an included angle that is half into 10 into 10 into sine of 60 degrees. That is 50 into 0.8660. That comes out to be 43.3 centimeter square. That is the answer for part B. Area of sector, which formula will you use? That is theta degrees over 360 degrees into pi into r square. Theta is 60, 360 is 360, pi is 3.142, that is 4SF, good enough. And this is 10 square. So this is 100 into 3.142. Hold for a second. 314, sorry, 314.2, 314.2 and divided by 6. That is 52.36. That is 52.36 centimeters square. And what is the area of the shaded region? Area of the shaded region is area of the whole sector minus area of the triangle. So area of the whole sector minus area of triangle, that is 52.36 minus 43.3 minus 43.3, that comes out to be 9.067, 9.067, that comes out to be 9.07 centimeters square. Final answer given to three significant figures. Now, how many of you got this thing correct? How many got at all correct. Okay. That's good. That's good. Now, remember the identity that I just taught you? So, what does it mean? What is this thing? This thing is SIN, sign of K. What is this thing? This is tangent of K. So sine divided by tangent is equals to cosine of K. Just a fun element. We know that sine divided by cos equals to tangent. So this tangent is right over here. This sine is right over here. So yes, it's a wonderful way of explaining the math stuff. When the sink is divided by tank, so this sink is SIN, sine of K. This is TAN of K. So since sine divided by cos is tangent, therefore sine over tangent is cos. So I hope you understood this meme loud and clear. So just a fun part. And over here, you can have another way of saying the same thing. That is sine of this angle K divided by cos of this angle K, that is equals to tangent of this angle K. Got the idea? So now that is about this. Now let's do one question from the P1 past paper. Now this is P1 9709 syllabus. This is paper number 1. And let's focus on this third part. It says in the case where theta is pi by 3, so this theta is pi by 3, so we have not studied gradients right now. Let's call it 60 degrees. Show that the exact length of the perimeter of this triangle ABC is this much. Now this is working in third form. So let me give you the answer. Sine of 60 degrees, that is root 3 over 2. Cos of 60 degrees is half. Just focus on this third part and let me solve it for you. Now, this is a better, clearer version of this. They are talking about the exact length of the perimeter of the triangle ABC. Now, we are talking about the perimeter of a triangle. So, first of all, let's join A and B. That is the first thing. Let's join A and C. That is all the way over here. Let's join the third thing, which is B and C. Now we are solving an A-level maths paper. There are different ways of doing it. I'll just do it by one way. First of all, if this is a semicircle, which it says in the beginning, the diagram shows a semicircle. So if it's a semicircle, if OA is 8, therefore OC is also 8 centimeter. That is the first thing. Now this angle is 60 degrees. Now this is 8, this is 8 because this is a radius. And we just saw this, that if this angle is 60 degrees, if it's an isosceles triangle, therefore AB is also 8 centimeter. So is everyone clear? Why AB? AB is 8 centimeters because of that isosceles 60-degree angle becoming equilateral triangle. Is this thing clear? Property. So just focus on this. This is exactly the same thing as we did over here. That was this one. This one right over here, the isosceles triangle, this was 60 degrees, this is 10, this is 10, these two also become 60, 60. So the isosceles triangle became and equilateral triangle. Is this all got all clear? I don't see that many likes over here. People, just be a little bit more responsive. So I hope this is all good, all clear. Now, someone, if they want to work it out, they are most welcome to work it out using cosine rule. They can do all the working. They can say this AB square is equals to 8 square plus 8 square minus 2 into 8 into cos of 60. That is perfectly fine with me. Let me do it for you. So therefore, over here, AB square, that is 8 square, 8 square minus 2 into 8 into cos of 60 degrees. We know that cos of 60 degrees is half. This 2, this half will cancel out. So therefore, I'm left with this thing. This is 8 square. This is 8 square minus 8 square. That is simply 8 square. So AB square is 8 square. Therefore, AB is 8 centimeters. That's one thing. Now, the only missing piece of the puzzle is this BC. Now, if this is 60 degrees, isn't this 120 degrees? Yes. Now I have 8 centimeters. Now I have 8 centimeters. I can find BC. So let me find BC using cosine rule once again. BC square, that is 8 square plus 8 square minus 2 into 8 into cosine of 120 degrees. And guess what? Cosine of 120 degrees, it's also half, but with a negative sign. You can check it using a calculator. I remember all these values, alhamdulillah. This is 8 square, this is 8 square, this negative makes it positive. 2 and this 2 cancels out, and this is 8 square. So now this is 3 times 8 square. There are 8 squares. That is equals to BC squared. Therefore, BC is square root of 8 square and 3. That is square root of 8 square, square root of 3, which is 8 root 3 centimeter. And I'm very sure that some people got lost in this one, even though CERD is part of O-level math syllabus. Got the idea? So now there were 8 squares. This time the negative became a positive. This negative made it a positive. 2 and 2 cancels out. This is also 8 square. So how many 8 squares do you see? You three of them. So instead of writing 64 plus 64 plus 64, that is 192, I wrote this thing as 3 times 8 square. Isn't this beautiful? And then I took the square root. So the square root of 8 square is 8. The square root of 3 is root 3. So I also found BC. So BC is 8 root 3. That is found. And last but not the least, what is the perimeter of triangle ABC? That is how many 8s? You see 1 8 and 2 8 and 3 8s. So that is 8 plus 8 plus 8 plus this thing, that is 8 root 3. So that is 24 plus 8 root 3 centimeter. Congratulations. Based upon the way that I have taught you, you have solved a question of P1 past paper. By the way, this is a P1 past paper question. I hope it's all got all clear. So that completes this class for today. Just acknowledge if you have understood everything loud and clear. The recording will be uploaded. Don't worry, you have to copy. Even before that, watch, copy, jot down so that you are all set for the next class. Take care, everyone. Allah Hafiz.